So our aim was to prove the theorem, the distribution of the area between two ordered statistics is independent of the form of the distribution of x. Okay. So we have started with that, the distribution, joint distribution of order statistics x1, x2, xn is nothing but, we already obtained, it is nothing but n factorial product of f of xi, where I running from 1 to n. And we assume that let ui is nothing but the distribution function of the ith order statistics, and which is nothing but the probability that x is less than or equal to xi is nothing but from minus infinity to integrate over minus infinity to xi fx dx, I running from 1 to n. So in short, the distribution function, we call them as a ui, and we know that what is the range of distribution function? It is 0 to 1. And when you take the derivative of distribution function, you will get the density function. That means dui is nothing but d of capital Fx, and that is nothing but a, a small fx. Thus, the joint density of u1, u2, un is nothing but n factorial into product of dui, and that is nothing but the du1 into dun, and where that u1, u2, un is lies between 0 to 1. So to obtain, because we wish to find out the area between the order statistics, let us, if we wish to find out the area between the smallest order statistics and the largest order statistics. So x1 is the smallest and xn is the largest order statistic. So if we wish to find out the area between x1 and xn, it is as good as that if we are trying to find out the area between u1 and un. So I told you that to find out the joint density of u1, un, we have to integrate the joint density of u1, u2, un by u2, up to un minus 1. So that is how it is nothing but f of u1 un is n factorial of integrate of u1 to un to un minus 1, then integration of u1 to u4 up to u1 to u3, and that is nothing but the, in fact, which, what is the lies between u1 and un minus, so that is un minus 1 is lies between u1 and un. Okay. Similarly, we have to proceed in that way. Un minus 2 is lies between u1 and un minus 2, un minus 1, and un minus 3 is lies between u1 and un minus 2, and similarly u2 is lies between u1 and u1. u2 is lies between u1 and u3. So you just integrate over this. If you take the integration of u2 with respect to, okay, if you take the integration of du2 in the range of u1 to u3, it is nothing but u3 minus u1. And if you take the again the integration of u3 minus u1 over u1 u4, it is nothing but u3 minus 1 square divided by 2 u1 to u4, but u3 is nothing but u4. So you will get the u4 minus u1 square by 2. And similar way you can integrate it, you will get n factorial into un minus u1 raised to n minus 2 upon n minus 2 factorial. This n factorial and n minus 2 is cancelled out in that way, so the remaining part is n into n minus 1. So this is what we have seen, the joint distribution of the smallest order statistics u1 and un, and that is nothing but n into n minus 1 un minus u1 raised to n minus 2 du and du1. Now let us obtain the area between the un and u1, because I am interested to find out the area between u1 and un. I am looking for this. Okay. So what I say that I will assume that v equal to un minus v, because if I am saying this is nothing but v. Okay. So v is nothing but un minus u1. So that is what it's saying, that I am interested to find out the distribution of the v. So let us say fixing v, if I'm say, let us say fix the v, so what is happen? Un equal to this u1 is this side, it is a v plus u1. Okay. So I am writing that un equal to v plus u1. Now what is the range of u1? We know that the range of u1 is u1 is less than u2 less than un less than 1. Okay, less than equal to. So this is the range of. So what is the range of u1? The range of u1 is lower range is 0. If you substitute the lower value of 0, what is that? What is that? Here the un become the v. So that means lower value of the un become the v. Now what is the range of maximum range of u1? So it has the, of course, it is a, this is your u1 and this is u1. So it is lies between 0 to 1. But if you substitute, if you say that here u1 equal to un minus v. So what is the maximum range of un? It is also lies between 0 to 1. So it is here maximum is a 1. So what is the range of maximum range of u1 is? u1 is lies between 1, sorry, 0 to 1 minus v. So that is how un is lies between 0 to 1 minus v. Now substitute the minimum range of 0. So that is un become the minimum value is v. Now you substitute the u1 equal to 1 minus v. So what is the un? V plus 1 minus v is nothing but 1. So un is lies between v to 1. And u1 is lies between 0 to 1 minus v. Now we wish to make the transformation from un to u1v. So we can use the Jacobian technique. Okay. So what is the derivative of partial derivative of? Here you can take the u1. u1 is as it is, so u1. So that is the du1. And v is equal to what? V is equal to this. If you take the derivative of v with respect to n, what will you get? It is a dv is nothing but dun. So that is how is as good as the du1 dv. And you have to substitute un minus u1 is nothing but v. So we are substituting the v in the above. So substitute the v, n into n minus 1. This is un minus u1 is v. So it is a n into n minus 1 v raised to n minus 2 dun. un की जगह पे क्या है आपका? dun equal to dv. So this dv into du1. So that is what it is written. So this is the joint density of u1 and v. Now I am interested to find out the density of v. So what I do, I have to integrate this joint density by variable u1. So I am integrate out using u1. So v is free from u1. So n into n minus 1 v raised to n minus 2 is constant out. And what is the range of u1? u1 is lies in 0 to 1 minus v and du1 dv. So dv is also constant, is outside. So du1 is nothing but u and u1. And what is the range of u1? It is 0 into 1 minus v. So you can write it as a 1 minus v. So that is how n into n minus 1 raised to v raised to n minus 2. And integration of this is nothing but 1 minus v. And what is the range of v? V is nothing but lies between 0 to 1. Okay. Is that fine? So if you are writing
Yes, sir.
in this n into n minus 1 v raised to n minus 2, 1 minus v raised to, can I write it is a power 1, so I can write 2 minus 1. And if I am writing the 2 minus 1, it is nothing but it is a beta distribution with parameter n minus 1 and 2. So I will show you. What is the beta? So beta has the density beta AB. We have seen that x raised to a minus 1, 1 minus x raised to b minus 1. In our setup, what is that? It is a v raised to, what is that? n minus 2 लिखा था, क्या लिखा था? n minus 2. So can I write in this way? V raised to n minus 1 minus 1 and 1 minus v raised to 2 minus 1. लिख सकते हैं ये, ठीक है। और यहाँ पे मैं अगर लिखता हूँ बीटा, तो what is a is n minus 1, and what is the b is a 2. So this is the density of the beta with n minus 1 2. So I will keep this part as it is. Now I will just write this. What is that? It is nothing but gamma n minus 1 into gamma 2, and in denominator it is a n minus 1 plus 2. Is it? Or I am making a mistake? Okay, बराबर लिखा है, ठीक है। So what is that? It is as good as v raised to n minus 1 minus 1, 1 minus v raised to 2 minus 1. Now what about this? It is a gamma n plus 1, and this is nothing but the gamma n minus 1. Gamma 2 is nothing but 1, or let us say it is gamma 2 as it is. This is as it is. Now gamma n plus 1 can be written as n into gamma n. Okay. So here it is a gamma n minus 1, as it is I can write, and gamma 2 is nothing but 1 factorial, so that is nothing but the 1. And this is nothing but I can also write in this way, n into n minus 1 gamma n minus 1. And this is nothing but the gamma n minus 1 into 1. So this will cancel out, so this part remain n into n minus 1. So that is how we have written that this is nothing but the density of the gamma distribution with n minus 1 and 2 parameters. Sorry, not gamma, it is a beta distribution with parameters n minus 1, 2. Okay, so this is the, what is the distribution of the smallest area between the smallest order statistics and the largest order statistics. If you wish to find out, it is nothing but the purely a beta distribution with n minus 1 and 2 parameters. Now, in general, instead of finding the distribution of the first order statistics and the area between the first order statistics and large order statistics, I am interested to find out the distribution between any two order statistics. Let us say the distribution of area between any two order statistics UR and US. So what is the UR and US? So suppose if I am writing in this way, if this is the UR, this is the US, okay, and there are n observation, then how many observations, how many U's precede the UR? So we know that it is a, how many? R minus 1 U's precede this. How many observation lies between the UR to a US? It is S minus R minus 1 U's lies between UR to US. And how many observation exceed the US? If it is a n, so it is a n minus s u. Okay, so that we know. So if I am writing first joint distribution, because I am interested to find out this distribution, the area between any two order statistics. But first I have to write down the joint distribution of the UR and US. So by using this, we can write, there are total n observations, so there is n factorial. How many observations precede the rth order statistics? It is the r minus 1, and each has the probability is the ur, so it is nothing but ur raised to r minus 1. How many observations lies between the us and ur? Okay, so it is s minus r minus 1. And what is the probability between the observation between the rth order statistics and s order statistics? We know that it is nothing but us minus ur raised to s minus r. And because the range of u is 1, so what is the order statistics? How many u's exceed the s order statistics? It is nothing but the n minus a. And what is the probability of each use? That is 1 minus f of x of xs. लेकिन हमने f of x ss को क्या लिखा है? us लिखा है. This is 1 minus us raised to n minus s. And divide by r minus 1 factorial, s minus r minus 1 factorial, and n minus s factorial. And then it is a PDF of UR and US. So this we know because we have already obtained the earlier. But I am interested to find out the area of area between the Rth order statistics and Sth order statistics. So it is as good as that I am trying to find out the area between the UR and US, and that is nothing but the US minus UR. US is nothing but here it is a distribution function of the excess order statistics. ये एक्चुअली हमने इसको नोमेनक्लेचर किया है, तो ये क्या है? इट इज ए x of xs and ur क्या है? इट इज ए fx of x of r. नोमेनक्लेचर भूलना नहीं है, ठीक है? us and ur is nothing but it is a CDF. us is nothing but it is taking the, what is this? fx is nothing but it is probability that x less than or equal to x of s small s, and we have given that r is less than s. So of course this value is smaller than this, so the probability is also a, this probability is the smaller than this, so of course you can subtract. I'm interested to find out the w, the distribution of w. So what I do, wherever the us minus ur I can write about w, and wherever the us, what I can write? Us equal to, I can write w plus ur. So you can see that here n factorial, it is n factorial, ur raised to r minus 1, it is a ur raised to r minus 1, us minus ur I am writing as a w, it is a w raised to s minus r minus 1, and here 1 minus us, 1 minus us equal to, I can write w plus ur, it is a 1 minus w plus ur, so it is become the minus minus, so 1 minus w minus ur raised to n minus s, and this part as it is f of ur, and us equal to, you can write w plus ur, it is f of w plus ur. Now what I do, I'm just trying to shift, or let us say this part as it is. Okay, now I'm just taking the common out, 1 minus w, so 1 minus w if I'm taking outside, it is 1 minus w raised to n minus s, and then 1 minus w by 1 minus w, it is a 1, and minus ur upon 1 minus w, and the power remain the as it is. Okay, and here it is a fr and fw plus ur as it is. Now what I do, I will divide ur by 1 minus w. So what is the power of ur? R minus 1. If I am dividing, first I multiply 1 minus w raised to r minus 1, and then I can divide. So what is the power? Power is nothing but ur raised to r minus 1. So earlier I have a 1 minus w minus n minus s is there. Now I will add this part. So it is become the 1 minus w n minus s plus r minus 1. Okay. Now there is a plus. Why there is a plus? So I will come to that. So now this ur raised to r minus 1 is written and this. So that term is here. This as it is. Now I am also dividing it is 1 minus w. Okay. So what is that? 1 minus w is from here. Is it? Because I have to multiply and then I have to multiply. So 1 minus ur upon 1 minus w. So this is, so 1 minus w I am dividing over here, so there is a plus sign here. And then w plus ur, that I have written as a w. Why? Why I have written w plus ur as a w? So what will you, okay. If you take the derivative of d of us is equal to what you can write? It is a d of w because ur is the constant. So that is us equal to, you can write d. That is not the issue. I will show you that why we have written this. You have two things. Here you have a ur into f of w plus ur. Is it? Now we know this relation w is equal to us minus ur. Okay. So if I am writing f of ur, so ur is nothing but w plus us. Okay. This is the ur. Here I am writing ur upon 1 minus w. Here I am writing w, and what is the ur? ur is nothing but w plus ur. If I am writing w equal to us minus ur plus ur, okay, so this will cancel out. It is a ws, and it is, let us say, b square series of fur. It is f of ur is equal to f of us. तो उसके बेस पे तो हमने लिखा था कि ur and w plus us. इसको बाकी रखिए, आपको मैं बाद में बताता हूँ कहाँ गड़बड़ हो रही है. Okay, so this is n factorial. W raised to s minus r minus 1 is here. This is 1 minus w raised to n minus s plus r minus 1, and this is quantity. Now, if you integrate out this, here this is a plus 1 and minus 1 is cancelled out, so it is a n minus s plus r, and w is constant out, so it is w raised to n s raised minus r minus 1, 1 minus w n minus s plus r, and this, so that is constant out, and the range of ur upon 1 minus w is lies between 0 to 1. So what is the integration with respect to ur? So it is 0 to 1, ur upon 1 minus w raised to r minus 1, 1 minus ur upon 1 minus w n minus s into d of ur 1 minus w. So when you integrate it, what will you get? This is nothing but the, if you say it is a, let us say x, so x raised to r minus 1, 1 minus x raised to n minus s, and dx. And if it is range 0 to 1, so it has a beta r and n minus s. You have to plus 1 and minus 1, so that is as the beta r n minus s plus 1. So if you write this, you can have n factorial, r minus 1 factorial. Now we, how this quantity is came. What you have a, you have a beta r n minus s plus 1. Okay, and here this quantity n factorial upon, okay, this quantity is with you, n factorial upon r minus 1 factorial into s minus r minus 1 factorial into n minus s factorial. Okay, this quantity is with you. Now beta r, so that is nothing but the gamma r into gamma, what will that? N minus S plus 1 upon, is it gamma R into gamma N, sorry, it is a gamma R plus N minus S plus 1. Okay, this is, you have a n factorial. It is, we can write it as a gamma R minus 1 factorial is gamma R. This is nothing but the gamma S minus R, and if you write it, this is nothing but gamma n minus S plus 1, because we know that gamma n is nothing but n minus 1 factorial. Okay, so this relation we know. So this will be cancelled out with this gamma r will be cancelled out with this. So what will you have? You have this quantity n factorial upon gamma r plus n minus s plus 1 into gamma s minus r. So if you add it, you can write it as n plus 1, and what is the sum of this? R plus r minus s, here s minus r, so that is cancel out. So you can have what remain? N plus 1, and that is nothing but this. So it is a r plus n minus s plus 1. This is gamma s minus r, and the denominator is nothing but the sum of this quantity is here. So it is nothing but the 1 upon beta r plus n minus s minus r minus 1, is it? Sorry, this is as it is, s plus 1. This is s minus r, and that is how, if you integrate this part will go in a numerator. So that is what they have written. This is nothing but, because 1 upon this quantity is equal to 1. So this quantity 1 upon beta r n minus r s plus 1. Sorry. Okay. Sorry. Here it is a 1 upon. So I am writing here it is a beta s minus r n minus r plus 1. So that we have obtained here. There. Okay. That is what we have written. Either you can write beta ab or beta a. That is no issue. So because here the power is s minus r first, so it is written the beta s minus r and then n minus s plus r plus 1. So this is also nothing but it is a beta distribution, which is a beta distribution with parameter s minus r and n minus r. If you wish to find out the distribution of any two order statistics, rth order statistics and the sth order statistics, and area between them, it is nothing but the beta distribution with parameter s minus r and n minus s plus r plus 1. Now we can deduce from that, if I am giving the r equal to 1, that is the smallest order statistics, and s equal to n, that is the largest order statistics. So you can see that it is a beta n minus 1, and here n minus n, so that is cancel out. So it is a 1 plus 1, that is the 2. So it is nothing but the area between the any two order statistics, that is the u1 n, ur and us is nothing but this. And if you wish to find out from u1 and un, it is a beta distribution with parameter n minus 1 and 2. So that we have already obtained. Okay. Any questions up to here? Anyone?
No, sir.
Okay. Now I wish I know that what is the distribution of the UI. So the PDF of the UI is nothing but f of UI is n factorial upon I minus 1 factorial upon n minus I factorial ui raised to I minus 1 1 minus ui raised to ni minus 1. ये हमने निकाला है ना, आगे हमने निकाला है, हमने ui की जगह पे उसको xi लिखा था, द डिस्ट्रीब्यूशन ऑफ ऑर्डर स्टैटिस्टिक्स xi. सही है. xr1 is nothing but n factorial upon r1 minus 1 factorial n minus r1 factorial. And instead of the this, if I'm saying it is a f of ui, okay, then r become the 1 I, so it is n factorial upon I minus 1 factorial n minus I factorial. This is ui raised to I minus 1 and 1 minus ui raised to n minus ui into f of ui. So that is what here I have written. And f of ui is nothing because ui is fx of ui, sorry, fx of xi. Okay, so d of ui is nothing but f of ui, sorry, f of xi. So that is how it is nothing but I have written it is a dui. So this is nothing but the distribution of or the PDF of I, where what is PDF of UI and where UI is nothing but it is the distribution of the ith order statistics. Okay. So I am interested to find out what is the mean of UI. Okay. हमने आपको बताया what is the range of UI. The range of UI is 0 to 1. Okay. So let us see what is the mean. So it is a n factorial upon I minus 1 factorial upon this. This is the constant out 0 to 1 because I am finding the expectation of EI, and we know that the expectation of x is nothing but integration of x fx dx over the range, whatever the range of x is there. Okay. So here it is nothing but expectation of EI is nothing but integration of ui fui di, and fui is nothing but this. So this part is constant ui into ui minus ui into ui raised to I minus 1 1 minus ui raised to n minus I into dui. Now this is nothing but ui into ui plus 1, so I can write it as a 0 to 1 ui raised to I की जगह मैं ऐसे लिख सकता हूँ I plus 1 minus 1 and 1 minus ui raised to n minus I du. Okay, so this is nothing but ये बीटा डेंसिटी का है, बीटा का फॉर्म है, so it is the beta of I plus 1 n minus I, and this is the n minus I plus 1 because it is a minus 1. हम ये जानते हैं ना, integration of 0 to 1 x raised to a minus 1 1 minus x raised to b minus 1 dx is equal to beta a b. तो यहाँ पे हमारा क्या आएगा, we'll have the beta I plus 1 and n minus I plus 1. So this is that. अब इसको आप सिंप्लीफाई करो तो क्या आएगा, गामा एन आई प्लस 1 गामा एन माइनस आई प्लस 1 अपॉन गामा I plus 1 plus n minus I. This I cancel out, it is n plus 2. Okay, gamma n plus 2. So this is nothing but n factorial is nothing but, you can write it as a, okay, you can write as it is. This is nothing but the gamma I. This is the gamma n minus I plus 1. ये कैंसिल है यहाँ पे, तो दिस विल कैंसिल आउट विद दिस विल कैंसिल आउट विद दिस. तो क्या बचा, n फैक्टोरियल. सही है, क्या बचा आपके पास, सॉरी दिस इज द गामा आई प्लस वन है, ये गामा आई है, तो यहाँ पे क्या होगा, I'll show you here nearby. क्या अपने पास है n फैक्टोरियल अपॉन I माइनस वन फैक्टोरियल इंटू n माइनस आई फैक्टोरियल, यहाँ पे क्या है बीटा I प्लस वन एंड देन n माइनस आई क्या है n माइनस आई प्लस वन, ठीक है, n minus I plus 1. Now this is nothing but n factorial. This is nothing but gamma I. This is the gamma n minus I plus 1. Okay. यहाँ पे क्या होगा, it is a gamma I plus 1. This is the gamma n minus I plus 1 divided by gamma n plus 2. Because I plus 1 plus n minus I will be cancelled out, and 1 and 1, 2. Okay. So I can write this as a gamma n plus 1, this is gamma I, this is gamma n minus I plus 1 into, this is I into gamma I, because gamma I plus 1 is nothing but I plus I into gamma I. This is that is gamma n minus I plus 1, and this is, I can write it is n plus 1 gamma n plus 1. So this cancel out with this cancel out with this will cancel out with this. So bacha kya? The last you can have remained, it is I upon n plus 1. So this is nothing but expectation of ui. So what is the expectation of ui minus 1? It is a I minus 1 upon 1 plus, sorry, n plus 1. So if you find out the spacing between the two order statistics, मतलब x1 और x2 के बीच का जो स्पेस है, एक्सपेक्टेड वैल्यू कितना रहेगा, ठीक है। तो यहाँ पे if I am interested to find out the spacing between the order statistics I and I minus 1, it is nothing but expectation of ui minus expectation of ui minus 1. It is the I upon n plus 1. This is minus I minus 1 upon n plus 1. And it is nothing but n plus 1 is common. It is I minus I plus 1. This is cancel out. It is the spacing is 1 upon n plus 1. So spacing between the two order statistics, the expected value of the spacing between the two order statistics is 1 upon n plus 1. तो यहाँ पे आएंगे तो आपको वही किया है. This is the expected value of ui is I upon n plus 1. And if you similar way you find out the expectation of ui minus 1, it is I minus 1 upon n plus 1. And so the difference between the expected value of the two consecutive order statistics is nothing but 1 upon n plus 1. That means if I wish to find out, this is the ui minus 1 and this is the ui, and if I wish to find out the area, but that expected the area, what is the expected area between the two consecutive order statistics, it is a n plus 1. Okay. Is that fine? Any questions up to this? Anyone? Good. No questions. Nice. Now I wish to find out the distribution of range. Range is nothing but the difference between the largest order statistics and the smallest order statistics. Xn is the largest and x1 is the smallest. So we know that the joint density of the smallest order statistics and largest order statistics, what is the joint density of u1 and u1 and un that we obtain here? It is a beta actually. What is that? It is a this n into n minus 1 un minus u1 raised to n minus 2 this. So that is what here we have. So if this x, if we writing instead of x1 x2 in the form of u1 and un, so we have this f of u1 un is equal to n into n minus 1 un minus 1 u1 raised to n minus 2, and this is f of, sorry, it is a d of u1 and d of un, but we know that ui is nothing but fx of x of I. Okay, तो u1 की जगह पे हम क्या लिख सकते हैं, fx of x1, un की जगह पे क्या लिख सकते हैं, fx of xn is the power n minus 1, du1 is nothing but fx of xn and fx of small xn. So this is nothing but the joint PDF of the smallest order statistics and the largest order statistics is given by n into n minus 1 fx of xn minus fx of small x1 raised to n minus 2 and small fx x1 and small fx xn. But I am interested to find out the range. Okay, so what is where you can find out? R is equal to xn minus xn. So I will take the transformation variable technique. Let us say x1 equal to y and r is equal to xn minus y, xn minus 1, x1. So I can write this r is equal to xn minus x1. So xn equal to what I can write? xn equal to r plus x1, और x1 को मैंने क्या कहा है, y कहा है. So I can write n into n minus 1 fx of xn की जगह पे r plus y. So that is what it is written, y plus r or r plus y. And here it is a fx of y raised to n minus 2. xn की जगह पे क्या लिख सकते हैं, f of y plus r, and here it is a f of y. Now I am interested to find out the distribution of range. That means I am interested to find out this. So what happen? I have here y and r, two variables, so I can integrate. It is joint density is given, so I am interested to find out the marginal density of r. So I can just integrate with respect to, if I have this, okay, so I can, if I am interested in this only, so I can integrate with respect to y. Okay, so if I'm integrating this with respect to y, we get the distribution of range. And what is that? It is integration, because we know that what is the range of y. We have not given here. If it is given in terms of u, I can have the range is 0 to 1. Okay, so I am here taking the range n minus infinity to infinity. This term is extra. This is additionally written, so this is not there. It is simply a f of x y plus r minus fx of y raised to n minus 2 into f of y plus r fy dy. Okay, so you can find out this. Now if you say that range of y, suppose range of y, not x, is like between a to b, okay, then y takes value minimum as a and its upper range is here, sorry, what is that? It is given that here you have written that xn equal to r plus y. So y is equal to, okay, it is xn minus r. Okay, so if you say that the range of this xn, not y, is lies between a to b, then what is the minimum value? Minimum value of y is a and maximum value is a b minus r. Okay, so this is you can have f of r n into n minus 1 a to b minus r fx y plus r minus fx raised to n minus fxy raised to n minus 2 small f of y plus r and small fy dy. Now let us understand. So this is nothing but the distribution of range. Okay, if I am interested to find out let the x1 x1 xn is a random sample drawn from the PDF fx is equal to e raised to minus x. then it is saying that find out the distribution of range and its mean. Okay, so here it is given the PDF. So first we find out the CDF of x, and it is nothing, capital Fx of x is nothing but 0 to x, because the range is x greater than 0, so it is start from 0 to x. Okay, and it is the e raised to minus y dy. So what is the, if you integrate it, e raised to minus y upon y, and if you just substituting this, you will get 1 minus e raised to minus x. ओके, ये तो सब जानते हैं ना, दिखाना पड़ेगा, चलो दिखाते हैं. What is given? F of x is e raised to minus x. So what is the capital Fx? So we know that it is a 0 to, let us say it will reach is e raised to minus y dy. So it is nothing but minus e raised to minus y, okay, and this is 0 to x. So if you just give the 0 first x, it is e raised to minus x, and then minus minus plus e raised to 0 is 1. It is a 1 minus e raised to minus x. Now what is the f of x y plus r? It is nothing but 1 minus e raised to minus y plus r. What is the fx of y? It is nothing but 1 minus e raised to minus y. Now I wish to find out the difference between this y plus r minus fx of y, and it is 1 minus e raised to minus y plus r minus 1 minus e raised to minus y. So what will you get? It is nothing but 1 minus e raised to minus y plus r minus 1 plus e raised to minus y. So this is cancel out. It is the e raised to minus y minus e raised to minus y plus r. Now what I do, I can just take the common e raised to minus y. What I can get? E raised to minus y, 1 minus e raised to minus r. So this is the quantity. So that is what here you can have. है लिखा है e raised to minus y into 1 minus e raised to r, about this raised to power n minus 2. ओके, एंड इसकी रेंज क्या है एक्सपोनेंशियल की? 0 to infinity, तो इट इज 0 to infinity. और यहाँ पे क्या है, हियर एफ वाई प्लस आर, तो एफ वाई पर प्लस मतलब जहाँ एक्स है वहाँ पे आपको क्या लिखना है, वाई प्लस आर, तो इट इज ई रेज टू माइनस वाई प्लस आर, एंड एफ ऑफ वाई इज नथिंग बट ई रेज टू माइनस वाई डी वाई. ठीक है, तो हम आर वाले टर्म बाहर निकाल लेते हैं. यहाँ पे 1 माइनस ई रेज टू आर रेज टू एन माइनस 2 इज आउटसाइड. यहाँ पे क्या है, ई रेज टू माइनस आर, तो वो बाहर ले लिया. अंदर क्या बचेगा, अंदर बचा आपके पास ई रेज टू माइनस वाई रेज टू एन माइनस 2 इंटू ई रेज टू माइनस वाई इंटू ई रेज टू माइनस वाई. तो ये क्या हो गया, ई रेज टू माइनस वाई रेज टू n minus 2 plus 1, this is cancel out, it is e raised to minus y raised to n, and it is nothing but e raised to minus ny. So that is what they have written, and you are taking integration of this. तो e raised to minus ny का इंटीग्रेशन क्या आएगा, इसका हम जानते हैं e raised to minus ny अपॉन माइनस n, और इसकी रेंज क्या है, 0 to infinity. तो अगर आप यहाँ पे क्या निकालेंगे, सपोज 1 अपॉन n में बाहर ले लूँ, तो अंदर क्या बचेगा, माइनस ई रेज टू माइनस एन वाई, 0 to infinity. इफ आई एम सब्स्टिट्यूटिंग हियर y इक्वल टू इन्फिनिटी, तो ई रेज टू माइनस इन्फिनिटी इज 0, एंड माइनस माइनस देन प्लस, तो ई रेज टू 0 क्या होगा, 1, तो इट इज ए 1, तो दिस इज बिकम दी फाइनली 1 by n. तो 1 by n यहाँ पे रखेंगे तो दिस n विल बी कैंसल आउट, तो क्या बचा, n minus 1 e raised to minus r, 1 minus r raised to n minus 2. Okay, so what is the expected range of, expected value of range? It is the n minus 1, 0 to infinity, r e raised to minus r, 1 minus e raised to minus r, n minus 2. Okay, So what will you get? If you just take the e raised to minus r equal to 1 minus e minus r equal to z. So what happened? E raised to minus r equal to 1 minus z. And if you take the derivative, it is a minus e raised to minus r dr is equal to minus dz, क्योंकि यहाँ पे आप लेंगे डेरिवेटिव तो क्या होगा, e raised to minus r as it is, and derivative of minus r is minus 1. Okay, एंड यहाँ पे राइट हैंड साइड में क्या होगा, डेरिवेटिव 1 इज 0, एंड z का डेरिवेटिव माइनस z का क्या होगा, इट इज अ माइनस dz. ओके, तो दिस इज e raised to minus r dr इज इक्वल टू, आप क्या सब्स्टिट्यूट करेंगे, dz. तो आप यहाँ पे e raised to minus r dr equal to, you are substituting the dz, and this equal to, you are substituting the 1 minus z. So it is nothing but the, okay, this is nothing but the z. So z raised to n minus 2. Okay, अब यहाँ पे दूसरा आगे बढ़ते हैं थोड़ा. e raised to minus r equal to 1 minus z. So minus r equal to, you can write, what you can write, log 1 minus z. ओके, एंड आर इक्वल टू आप क्या लिख सकते हैं, माइनस log 1 माइनस जेड. एंड हम जानते हैं माइनस log 1 माइनस जेड इक्वल टू क्या लिख सकते हैं, जेड प्लस जेड स्क्वायर बाई 2 प्लस जेड क्यूब बाई 3 up to this. Why I have done this? Because I have the r quantity. Why r? R is here. Okay, so e raised to minus r dr equal to, I can write dz. This is nothing but z, so it is a z raised to n minus 2 dz. But r की जगह पे मुझे क्या लिखना पड़ेगा, I have to write this. So that is how I have written the. अब यहाँ पे 0 to infinity 1 में कैसे कन्वर्ट हो गया रेंज, because if the range of r is infinitive, then z become the e raised to minus infinity is 0. So that is 1 minus 0 is 1. So z become 1. And if your r equal to 0, e raised to 0 is 1. So 1 minus 1 is 0. So therefore the range of z is lies between 0 to 1. So it is n minus 1, 0 to 1, z plus z squared by 2 plus z. Likewise it will infinity and z raised to n minus 2. तो यहाँ पे आप z अंदर ले जाएंगे तो क्या होगा, z raised to n minus 1 plus z raised to n by 2 plus z raised to n plus 1 by 3 likewise. So if you take the integration of z raised to n minus 1, आपके पास ये क्वांटिटी है z raised to n minus n by 2 plus z raised to n plus 1 by 3 likewise up to dz. So इसका डेरिवेटिव विथ रिस्पेक्ट टू z, इंटीग्रेशन विथ रिस्पेक्ट टू z, if you do, what you will get, it is a z raised to n minus 1 plus 1 upon n. So that is nothing but 1 by, if you, because here the range is 0 to 1, it is a 1 by n. यहाँ पे क्या मिलेगा, 1 upon 2 n plus 1, यहाँ पे 1 upon 3 likewise. ओके, और यहाँ पे आपके पास क्या है आगे, n minus 1 तो बैठा ही है. तो n minus 1 हर एक को इसके साथ मल्टीप्लाई करेंगे तो क्या मिलेगा, व्हाट विल यू गेट, n minus 1 upon n plus n minus 1 upon 2n plus 1 up to this. So what will you get, तो बता सकता है क्या मिलेगा, n minus 1 आपको ये मिलेगा n plus n minus 1 upon 2n plus 1 plus up to this. So what will you get, if you divide this, it is a 1 minus 1 by n plus, यहाँ पे क्या होगा, आप जैसे इसको आपने ऐसे लिखा 1 by 2 माइनस 1 अपॉन n प्लस 1. अब ये n प्लस 1 यहाँ जाएगा तो क्या होगा, n प्लस 1, ये 2 उधर जाएगा तो क्या आएगा, माइनस 2. तो n प्लस 1 माइनस 2 अपॉन 2 n प्लस 1 क्या होगा, इट इज ए n माइनस 1 अपॉन 2 n प्लस 1. तो यही क्वांटिटी है n minus 1 upon 2n plus 1. So I can write this. So similarly 1 upon 3 minus 1 plus n by 2. Likewise ऐसे ऐसे करते गए आगे. तो ये 1 minus n will be cancelled out with this. Then 1 minus n will be cancelled out the previous one. Likewise. तो finally आपके पास क्या बचेगा, 1 plus 1 by 2 plus 1 by 3 up to 1 upon n minus 1. And this is nothing but the Euler constant. Okay, So expected value of range is nothing but if you have the n observations in order statistics, then expected value of range will be 1 plus 1 by 2 plus 1 by 3 up to 1 upon n minus 1. Any questions? Anyone up to this? Hello, am I audible?
Yes, sir.
So any questions? Anyone?
No, sir. No, sir.
So we have obtained the here we learn the concept of the order statistics. We obtain the joint distribution of order statistics. We obtain the minimum distribution of the minimum order statistics, maximum or the PDF of the maximum order statistics. Okay, we have obtained the distribution of range. We have obtained the joint distribution of any two order statistics. We have obtained the distribution of range. We have obtained the distribution between the area of two order statistics. Okay, तो हमने देखा कि you can find out the area of any two order statistics, different area between the any two order statistics. It is free from the distribution. हर एक का ओरिजिनल डिस्ट्रीब्यूशन चाहे कुछ भी क्यों ना हो, ठीक है. हमें हमारा जो एरिया आएगा, एरिया का डिस्ट्रीब्यूशन दैट इज फ्री फ्रॉम द ओरिजिनल डिस्ट्रीब्यूशन. तो यहाँ पे हमें हर चीज़ में क्या मिल रहा है, बीटा मिल रहा है. देन वी हैव सीन वन एग्जांपल्स. वी आल्सो फाइंड आउट द एक्सपेक्टेड वैल्यू ऑफ द difference between two order statistics. So that we also obtain, and that is we obtain it is a 1 upon n plus 1. So in next lectures, we will discuss about the quartiles, and then we obtain the distribution of a simple quartiles. Okay. So as I told you, okay, if you are finding the quantiles and quartiles are the difference. Here we are interested to find out the pth quantiles. So xi p is nothing but the pth quantile. But when you talk about the quartiles means it is dividing area into the four equal parts. This is the median, this is the first quartiles, this is the second quartiles, and this is the third quartiles. This area is 25%, this area is 25%, this is also 25%, and this is also 25%. Okay, so if I'm interested to find out these quantiles, okay, or if I wish to find out the distribution of the quantiles, so here it is saying that if a random variable x has the distribution function fx with the probability function small fx, then the pth quantile or fractile denoted by the xi p is given by probability that यहाँ पे ये आएगा लेस देन और इक्वल टू p, यहाँ पे गलत लिखा है, this is not, this is equal to. Okay, it is a probability that x is less than or equal to xi p is nothing but p. And what about the probability of x greater than xi p? It is a 1 minus p, because these two are complement of each other. Suppose if you are saying that this is the pth quantile xi p, so what is the area, what is the probability this, and what about this? So this is nothing but the your random variables x. Okay, this area is nothing but where x is less than or equal to xi p, and this area where x is greater than xi p. So what is this? So it is nothing but the CDF. So we wish to find out what is the probability that x is less than or equal to xi p. Okay, so we call them as IP. That means we are talking about the pth quantiles. So we call them as a P. And what is the range of P? P is lies between 0 to 1, because the total, this is the area under the curve, and this probability is nothing but 0 to 1. So the IP is the cutoff point. So what is the probability? So this area is said to be a P, So what about this? This area is said to be 1 minus p. So probability of x less than equal to psi p is equal to 1 minus p. Suppose if I take that p equal to half, that means this is nothing but probability that x less than equal to psi of half is nothing but half, and psi of half is nothing but when your area, when I'm writing that this cutoff point is psi half is dividing area into the two equal part. This has the probability 1 by 2 and this has the probability 1 by 2. Then psi half is said to be a median. It is called a median. Okay, that is called the median. तो सिमिलरली आपने बीएससी में पढ़ा होगा परसेंटाइल. Percentile means it is you can have a P12, P99. That means it is dividing area into the equal 100 parts. Okay, percentiles को आप quantiles भी कह सकते हैं. Okay, and if you say P50, P50 is nothing but it is a Q2. Okay, it is said to be a D5. Q2 means second quartile. This is called the fifth decile. This is called the 50th percentiles. Okay, so they all are nothing but the same. But we wish to find out if some distribution is given, what is the distribution of, let us say, median. So if I wish to find out the median, then I have to just write in this way. That probability this, and then I have to integrate this, compare this, I will get the value of this I2. जैसे हमने नॉर्मल डिस्ट्रीब्यूशन में निकालते थे, probability of z is less than equal to z alpha is nothing but alpha. Okay, so what is the value of z alpha? तो अल्फा 0.05 है, तो z अल्फा की वैल्यू क्या है? तो नॉर्मल डिस्ट्रीब्यूशन से आप निकालते थे. यू आर यूजिंग दिस काइंड ऑफ कॉन्सेप्ट. z अल्फा इट इज f ऑफ z अल्फा इज इक्वल टू अल्फा. और यहाँ पे आप नॉर्मल डिस्ट्रीब्यूशन लेते थे. यहाँ पे z अल्फा की जगह पे आप y ले लो, एफ वाई डी वाई. या z लो. ठीक है. तो दिस इज वे यू कैन फाइंड आउट दी z अल्फा. तो नेक्स्ट लेक्चर्स में हम इसके बारे में बात करेंगे, हाउ टू डिराइव द डिस्ट्रीब्यूशन ऑफ क्वांटाइल्स एंड सेकंड सिंपल क्वांटाइल्स. ये यहाँ पे ये वाला है. ठीक है, दिस विल ऑब्टेन. तो आपको आई ऑलरेडी टोल्ड यू, यू हैव टू प्रिपेयर योर नोट्स. आपको आपकी नोट्स लिखते रहनी है. अगर नहीं लिखेंगे तो साथ में इकट्ठा कुछ नहीं होगा. ओके, so it is not, you have to just see the video and try to prepare your own notes. PDF already sent to you. Any questions, anyone?